So once we have calculated our quartiles, then we must find the interquartile range. So remember in the beginning I said that the range is the difference between the highest value in your data set minus the lowest value in your data set. So again here, when we talk about the interquartile range, we refer to that as my upper quartile minus my lower quartile. Okay, so in example number 1, my interquartile range would be 13 minus 3, which is 10. Number 2, my interquartile range would be 15 minus 3, which is 12. And in example number 3, my interquartile range would be 82 minus 45, which is equals to 37. And then from there, we have what we call the semi-interquartile range. So the semi-interquartile range, is basically the interquartile range divided by 2. Okay, so let's continue with an example where we're going to do everything that we have learned. Okay, so now let's say you are given this data set, all right, and you are asked to find our measures of dispersion and those of central tendency. So first things first, what do you need to do? You need to arrange the set in ascending order, all right? So now let's do that. So we're starting off then with 3, it's the lowest, and it's followed by 2 6s. So we have a 6 and a 6, and it's followed by 2 7s. So 7 and 7, and this is followed by 1 8 and 1 9. Okay, do you have a 10? Yes, it's followed by a 10, and we have 1 2 3 11s. Okay, then we have a 12. Yes, we have a 12. And then we have a 14. And then we have a 19. All right, so there, my data is now in ascending order. So, firstly now we are asked to calculate the mean. So, when you're calculating the mean, we write it like that. So the mean would be us adding all these values. So we write it, normally we write it as this implies the sum. Okay, so the sum of my x values. So we say x1, so the I, we substitute it into here. So it's x1, which is my first value, x2, which is my second value, x3, which is my third value, all the way towards the end. So this end tells you the number of values, all right? And then you're dividing it by that number of values. So here then it's going to be so it's 134 divided by how many observations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So n is equals to 14. So 134 divided by 14, it gives me 9,6. So that is my mean. Okay. Now the other one, it's my median. Okay, so my median, let's use the way, the method that we used in the beginning. When n is 14, we divide n by 2, so it's 14 divided by 2, which is 7. So then it tells me that my median must lie there. So I must count 1, 2, 3, 4, 5, 6, 7 this way. Okay. And here I must count again 1, 2, 3, 4, 5, 6, 7. So these here are my two middle values. So my median is going to be 10 plus 9 divided by 2, which gives me 9,5. Okay. Then I must find my mode. So that is the most repeated number in my data set. 6 is being repeated twice, 7 is repeated twice, but 11 is being repeated 3 times. So the one that's been repeated the most would be the number 11. Okay. Then to calculate my range, okay, so my range is my maximum value subtracted from my minimum. Okay, so this here is going to be 19 minus 3, which is equals to 16. So that is my range. So now if we were to move on to the quartiles, all right, so picking up from here, if we're using the second method, so picking up from there, we know already that Q2 is equals to 9,5. Okay, so my median is here. So then it means I cover all these values from where my median was, and I only look at the values on the left-hand side of my median. Okay, and then I find the median of those those values. So if you look here, okay, my median is between these two here. Okay, look again, I'm covering my median and I must find the median of these 6 values here. So the median of those 6 values is the 2 values that are in the middle, and I find the average between the 2. So therefore here my Q1 is going to be 6 plus 7 divided by 2, which is 6,5. And my Q3 is going to be, I do the same. I cover this side here and I look at the remaining values and I find the median of the of those values. So here the median is between 11 and 12. So therefore Q3 is going to be 11 plus 12 divided by 2, which gives me 11,5. So that's the one method you can use. The other method now, okay, we're going to use those formulas. Remember, where we say Q1 is equals to a quarter times 14 plus 1, because n is equals to 14. So 15 divided by 4, okay, it tells me that my lower quartile is in this position. Okay, so it tells me the position. That's not the answer, it's just the position. So then I must go to my third and fourth position. So my third and my fourth position. And when I calculate Q1 now, I say Q1 is equals to my third position, the value in my third position, plus When I subtract 3 from there, I'm left with 0.75 times. Then I subtract the fourth value and the third value, so which is 7 minus 6, and therefore my lower quartile is actually then 6.75. Okay, notice that they do the values do vary. Okay, but both methods are actually correct. Then, how do I find my Q2? So Q2, the position again, it's a half of 15, yes. So this tells me it lies in between the 7th and the 8th position. So therefore, Q2, my median, all right, I take the value that's in the 7th position. So I count 1, 2, 3, 4, 5, 6, 7. 7th position, it's 9, plus I take away the 7 here, I'm left with 0.5, all right? Then I take the 8th value, which is 10, and I subtract the 7th value, which is 9. So here, my median quartile is 9.5. So just as we had calculated it before. And then to calculate the upper quartile, all right, I find 3 over 4 times 15. So that gives me, it lies in this position there, 11.25, all right. So it lies between the 11th and the 12th position. So now I must count. If this was the 7th position, so 8, 9, 10, 11, okay. So the 11th position is actually 11, all right. And if I then subtract 11 from there, I'm left with 0.25, okay, multiplied by the 12th position, which happens to be a 12, minus the 11th position, which is 11. So here, my lower quartile is 11.25. Again, whether you use this method or that method, okay, both methods are correct, even though there might be a slight variation in the answers, that's still fine. So it's really up to you whichever method you want to use, all right? And now if we were to then find the interquartile range, so the interquartile range in this instance here will be 11.5 minus 6.5, which is equals to 5. And therefore the semi-interquartile range is 5 over 2, which is 2.5. And you can apply the same for these ones as well.